So today we've been tasked with finding the plane equation given a line that is inside this plane and another plane which is parallel to it. So to start off, let's just find another point, or just a random point on this plane. So using this line, we'll just set t equal to 0, which means that we have a point at 1, 2, and 4. And this is going to be a point on this plane. And then we just need to find some perpendicular vector which we can use to say that it is in contact with this plane. And since we have a parallel plane, so let's just say that this plane is down here, we can use the normal vector of this plane, which is going to be the coefficients attached to each variable, which is 5, 2, and 1, to set up an equation to basically say that this point is perpendicular to this variable, which this plane will be perpendicular to this line. And if that doesn't make too much sense, we'll just set the equation up first and I'll try to explain it more. So we have the normal vector, so we're going to do 5 times the x position of this point, which is x minus 1, plus 2, multiplied by the y position of that point, plus 1 times the z position of that point, equal to 0. So why we set it equal to 0? If we look at a dot product example where we say a times b is equal to 0, this means that these two vectors are orthogonal. So in setting this equation equal to 0, we're saying that each point of this is orthogonal or perpendicular to these points, or is, in general, it's perpendicular, and we can use that to say that this plane, which is parallel to this plane, they are perpendicular to each other on this line. So then we just have to expand this equation. Plus 2y minus 4 plus z minus 4 equals 0. So we're left with 5x plus 2y plus z minus, this will be negative 9 minus 4, which equals negative 13. So then we have negative 13 equals 0, and then we just move the 13. You don't have to, but this is the equation for our plane.